Welcome to the video lecture on course code U18Pcit601 Grid and Cloud Computing. And I'm Dr. B. Dhanalakshmi, Professor, Department of Information Technology, Bharat Institute of Higher Education and Research. And today we are going to see Unit 2, topic Grid Services. So we will first see what is the OGSA standard which we are following for grid computing. So the acronym for OGSA is Open Grid Service Architecture. So OGSA define how different components in grid interact with each other. An open grid services architecture has the set of standards which define the way in which information is shared among diverse components of large heterogeneous grid systems. And in this context, a grid system is a scalable wide area network that supports resource sharing and distribution. So this architecture mainly deals with wide area network, and it concentrates on the resource sharing in the distributed network. And grid computing allows network resources to be combined irrespective of the platforms and being used. And grid computing offers great benefit to an organization. And OGSA are comprehensive standards which governs grid computing. And now we will see the architecture of OGSA. Here, the architecture of OGSA comprised of four main layers. The first layer being physical and logical resource layer, and the second layer web service layer, and the third layer is OGSA architected grid services layer and grid application layer. So here is the OGSA architecture where we have the service and the storage, OGSA enabled storage and the OGSA enabled network devices here on the bottom architecture of the OGSA, and here service, storage and network deals with the security issues, workflow, database management and file system management, then directory management and messaging. And top to it, we have web services through which the users interact. And we have open grid services infrastructures, that is OGSI, and above which the OGSA architected services are placed. And the top layer here is applications, through which the user will interact. And first, we will now see about OGSA architecture, physical and logical resources layer. The physical resources are servers, storage, and network. And logical resources here manage physical resources. And examples of logical resources, say database managers and storage elements and workflow managers. And now we will see about the web services layer in OGSA architecture. The web service is a software which is available online that could interact with other softwares in the platform using XML code. And the Open Grid Services infrastructure consists of sub-layers, and which denotes the grid services and provide a consistent way to interact with the grid services with higher performance. And this web services layer also extends the web service capabilities and thus enhancing the performance of the grid computing. There are 5 interfaces in OGSA architecture, namely factory, which provide the way for creation of new grid services, and then life cycle interface, which manages the grid service life cycles, and third interface state management, which manage the grid service states, And the fourth interface, which denotes the service groups, which is the collection of indexed grid services. And the last interface is notification, which manages notification between services and resources. And here is the OGSA architecture web services layer diagram. So here the web services consist of the life cycle interface and then the state management, and it also concentrate on service groups, factory, notification and handle map. So here it relates to the OGSI, that is Open Grid Services Infrastructure, which is on the web services layer. And now we will see about OGSA architecture, architected services layer there. So it is mainly classified into three service categories. First one is grid core services, grid program execution services, and grid data services. So the OGSA architected services, which is grid core services, composed of four main types of services. The first one is service management, which assists in installation, maintenance, and troubleshooting the different tasks which is distributed in the grid system. So each and every task that need to be installed with any tools or maintaining or debugging, that is troubleshooting every individual task which are to be done in a distributed framework in the grid system need to be managed. And the second type of service here is service communication, which include the functions that allow the grid services to communicate. So this type of service is mainly responsible for transferring the information from one network to other network in the grid computing. So, and the third service is policy services, which provide the framework or the rules or the protocols for creation, administration, and management of policies for system operation. And the last type here is security services, which provide the authentication and authorization mechanism to ensure the systems interoperate securely. So when the system from one network to another network, when it wants to interact, we need the authorization or authentication to enter the framework. So these four main types of services are very mainly important for the grid core services. So where the first service management, concentrate on the task execution in the grid system, and service communication, which gives importance to the grid services communication from one network to another network, and the policy services concentrates on providing the protocols or the rules for the administration and the management of the grid systems. And finally, the security services mainly provide the authentication for every network to enter into the other network in the grid computing. And here we are going to see OGSA architected services, which is related here as grid program execution services layer. So this supports the unique individual grid systems in high performance computing and collaboration and parallelism. And this also supports the virtualization of resource processing and resource sharing. So this grid program execution service mainly concentrate on how to integrate the different systems in the grid computing network and thus producing the high performance out of it. So it needs to be synchronized. Each and every task should be synchronized among the different network in the grid system. And while considering the resource management, we need to share the resources among the different systems in the network, which is in the grid system. So we need to go for the virtualization of the resource processing. And now we will see the grid data services where we support the data virtualization, and it also provides mechanism for access to distributed resources such as databases and files, etc. So here the grid application layer, which mainly comprise of applications that use the grid architected services. And here is the OGSA architected services layer diagram. So where we have the extended web services, which is in the form WSDL, which is dynamic, addressable, stateful, and manageable. And we have grid program execution services and grid core services and grid data services, which all are related to the domain specific services. And now we will see Open Grid Services infrastructure. And here it gives a formal and technical specification of what a grid service is. So it's all about metadata about the grid service, which gives a technical details about the grid service. So it gives a detailed specification of how grid services work. So it gives a detailed explanation about each and every execution of the task involved in the grid services. So this GT3 grid services mechanism includes a complete implementation of OGSI. It is a formal and technical specification of the concepts which are described in OGSA. The Globus Toolkit 3, that is GT3, is an implementation of OGSI. And even there are some other implementations, that is OGSI Lite, Pearl 1 and the Unicore OGSA Demonstrator 2 from EU GRIP project. So here this infrastructure brings in the technical details about the grid services that are involved in the particular task. So now we will see the Open Grid Services infrastructure where we create an extension model for WSDL called GWSDL, that is Grid WSDL. The reason here is it has the interface concept, that is inheritance, and the service data for expressing the state information. And there are various components here which involves a life cycle, state management, service groups, factory, notification, and handle map, which is on web services layer. And now we will see the data intensive grid service models. The applications in the grid are normally grouped into two categories, and the computation intensive and data intensive. The data intensive applications deals with massive amounts of data. So this data intensive applications give importance to data, and the grid system must specially designed to discover, transfer and manipulate the massive data sets. So here the data, heterogeneous data from the different networks are collected, transferred, and they are manipulated as per the requirement of the task. So the massive data here is going to be handled in the data intensive applications. So the massive data sets are transferred, which is a time consuming task. So since the data goes the big data concept, so here the processing the data is very difficult with respective to the time and even the memory. The data access method, which is also known as caching, here which is applied to enhance the data efficiency in a grid environment. So here we are going to see the data intensive grid service models, the methods, that is the strategies of replications. The replication strategies here determine when and where to create the replica of the data, how the cloning of the data is done, So the strategies followed are classified into two methods. One is dynamic method and other is static method. The static method involves the locations and the number of replicas which are determined in advance and which cannot be modified. So we need to predetermine the location and the number of replicas here in the static method. The replication operation require little overhead which may consume time and memory. Static strategic cannot adapt to any dynamic changes according to the demand, bandwidth, and storage variability. So when the demand changes and when the bandwidth changes occur, or when the storage capacity changes, so the static strategic will not adapt to the changes. So the optimization here is required to determine the location and the number of data replicas in static method. And now we will see about the second strategy, which is dynamic strategy. So dynamic strategy can adjust locations and number of data replicas according to the change in the conditions. The frequent data moving operations can result in much more overhead than static strategies. So optimization here may be determined based on whether the data replica is being created, deleted, or moved. So the dynamic strategies always adapt to any changes that occur in the data or the memory storage variability, and also it will just adapt to the any environment in which it is going to execute. And now we will see about the grid data access model, how the grid data can be accessed. So in general, we have four access models which are mainly for organizing the data grid. So once we decide on the capacity of the data grid, the next thing is you need to concentrate how the data grid has to be organized. So we have here four methods: monadic method, hierarchical model, federation model, and hybrid model. So these models will decide how the data can be organized in a data grid, which involves a number of networks involved in the distributed environment. And now we will see about the monadic method. So here the monadic method is a centralized data, which is like a repository model. And here all data is saved in central data repository. So we have here a centralized network where the data is getting reposited. And when the users want to access some data, they have no submit request directly to the central repository. That is, they have to interact, the users cannot interact directly to the central repository. They have to interact through some intermediary. And no data here is replicated for preserving data locality. So here the data replication is not adaptable here. So for in case of preserving the data locality, for a larger grid, this model is not efficient in terms of performance and reliability. So when the grid size increases, this model cannot be adapted, and this will definitely give compromise in case of performance and the reliability. So here we always maintain, we need to maintain the centralized data repository model. So we have to be knowledgeable while building the central data repository. Like all data here saved in the central data, which is going to be referred by the different grid models. And here the user interaction, direct interaction is not at all possible And this should be done through any brokers or the intermediaries. And again here, the data cannot be cloned. So thus preserving the data locality. So this will just reduce the memory that is occupied by the particular grid model. So when big data is considered, this model will be a failure model in terms of performance and the accuracy. Hence, we cannot go for monadic method for the big data analysis. And the second model is hierarchical model. So this hierarchical model is suitable for building a large data grid which has only one large data access directory. So this hierarchical model mainly will be a large data grid and which comprises of a number of tasks and number of subtasks inbuilt which forms a hierarchical form. And the data here may be transferred from the source to a second level center. So we have a different levels of hierarchy built in. So where level 0, level 1, level 2 and so on. So then some data in the regional center is transferred to the third level center here in the hierarchical model. So after being forwarded several times, the specific data objects are accessed directly by the users. So here the higher level data center will have a wider coverage area. The PKI security services are easier to implement in this hierarchical data access model in real time. So this hierarchical model is very suitable for large data grid since it forms a hierarchy where a number of models are integrated in a hierarchical form and which can be accessed level by level. And you can see the diagram for monadic method where the central data repository is maintained and which can be recorded using tapes or any other memory sensors. And we have instruments here to write the data into the central data repository and also to read. And here when compared the hierarchical model, we have different levels in the framework where the grid models form the different hierarchical form in the distributed network. And now we will see about the federation model. It is suited here for designing a data grid with multiple source of data supplies. So here the multiple sources of data grid are involved in the federation model, which is also known as mesh model. The data here is shared and items are owned and controlled by the original owners. And here the data cannot be shared other than the original owners until they give the permission, that is authentication, to the other users. So only authenticated users are authorized to request the data from any source. So this federation model will be suitable very well when heterogeneous data sources are involved in the grid computing. So in this model, we can see a number of nodes which are interconnected with one another in the diagram. So here the data can be shared from the repository, but the data access is only possible by the original owners or the authenticated users who are integrated after the authentication process. So here, once the request from the authenticated user is submitted, the data access permission will be given to the user. And here is the hybrid model. And this model combines the best features of the hierarchical and mesh models. We can also combine the other models in the hybrid model. So monadic model and hierarchical model together, or monadic model and mesh model together, or monadic, hierarchical and mesh models all together forms a hybrid model. So more than two or more forms, that is two or more forms when combined, then it forms the hybrid model. Always the traditional data transfer technology we all know, such as HTTP, FTP, which are applied for the networks with even lower bandwidth. The high bandwidth networks are exploited by high speed data transfer tools such as Grid FTP developed with Globus library. And here the cost of the hybrid model can be traded off between the two extreme models of the network. And you can see here the diagram which combines the hierarchical model and the mesh model. So the mesh model here involves the region and the institute connections. And the hierarchical model involves here the root node to the region node. So this model combines here always two or more combinational forms of the models. So already we saw about monadic method and hierarchical model and federation model, right? So this hybrid model can combine any of the two or more forms together in a network. So always we need a protocol here to apply for the networks to interact, that is for sharing, for communication purpose. And now we will see the parallel versus stripped data transfer. So first we will see all about parallel data transfer. This parallel data transfer opens the multiple data streams for passing the subdivided segments of the file simultaneously. So parallelly, what happens? We open the multiple data streams for message passing, where we get subdivided segments of different files or different storage elements. So here each one is considered as a separate individual task and are executed parallelly, or that is simultaneously synchronizing all the works. Although the speed of each stream is same as in sequential streaming. And here the total time to move the data in all the streams can be significantly reduced when compared to the FTP transfer. And always in grid computing, we go with executing a number of tasks in a framework. In that case, we can go for parallel data transfer where each and every task independently can run on the framework. So here we need to follow the protocol while transferring the message or the data from one network to another network in the distributed field. And the next we are going to see about stripped data transfer. And in stripped data transfer, the data objects is partitioned into a number of sections, and each individual section is placed in an individual site in the data grid. So every time the data grid will allocate the individual site or individual ID for each and every task assigned. So here the stripped data transfer will divide the data object into a number of units, and each unit will be placed in the individual site in the data grid. And when the user requests any piece of data, the data stream will be created and will be connected. That is, we need to open the connection with the particular stream for each site in the data grid. And through that connection, we can access the requested data from the data grid. Always, when the user requests this piece of data, the data stream will be created and all the sections of the data objects are transacted simultaneously. So every unit which are divided will respond to the query and can be, that is the data retrieval result will be returned to the query user, which is passed by the user depending on the performance of the data grid. And here this parallel versus strict data transfer is used in the grid services. And mainly parallel data transfer will give the higher performance.